Welcome to this new deep dive. Today we are going to get into the vocabulary of artificial intelligence that, sometimes brings them. In fact, the idea came from a very good anecdote. Someone who confused SOTA state of the art with a basement.
Yes, I heard it clearly. A signal that these ideas could use some thorough explanation, don't you think?
Totally. So our mission today is that to translate this sometimes intimidating jargon into something that good we can all understand. We will use a beginner's path as a reference, going from the general to the specific.
Exactly. Like a map, we start with the overview, the complete picture, and then we go down the important details to build a good, perfect base.
Well, let's see. The first idea is to visualize the IA as those Russian dolls, not the matryoshka.
The largest concept here is artificial intelligence, AI, in a broad sense.
That's people. They require human intelligence. Reason. Learn the typical example. A deep blue playing chess. Of course, we could make an analogy with the concept of transportation, the most generic.
Exactly. And within AI, we find machine learning, ML. This involves systems capable of learning independently from data inputs. That is, not programs for each specific little thing, but they identify patterns and create models to predict.
I like spam filters or Netflix recommendations, no.
Exactly, those are very clear examples. DML following your transportation analogy, since ML cars would be an important part of transportation, but not everything.
Understood, and there's something else inside?
Right, and then there's an even narrower category. Deep learning, DL, which represents an advanced subset.
Deep learning goes even deeper into AI.
POCO is a type of machine learning that uses artificial neural networks with many layers. That's why deep ones are very good at finding super complex patterns in raw data, images, sound, text.
Okay, and they need more power, I imagine.
A lot. A lot of data and a lot of computing power would be like the autonomous electric cars in your analogy, the most sophisticated thing right now.
These neural networks somewhat function like a brain.
Well, they're very loosely inspired by the structure of the brain, with layers of connected neurons they serve by adjusting the strength of those connections. And the star application of deep learning today is generative AI.
The one who creates new things, not texts, images.
That's like ChatGPT for text or DALL-E Midjourney for images. They are models that, after seeing millions of examples, can generate original content, like an artist who learns a style and creates new works.
Very clear. Now let's change a little third. How do you cook one of these models? Because we hear about algorithm and model. It's the same thing.
Good question. No, not exactly. To see the algorithm is like the kitchen recipe. Do you know the instructions set the process that the machine follows to learn from the data?
The recipe, okay?
And the model is the end result. It's the cake already baked, let's say. It's the system already trained, ready to make predictions or generate whatever.
Yes, and the ingredients in the recipe would be the data provided for learning.
The dataset is correct, the collection of data that we give the algorithm to learn. And be careful, the quality of that data is vital here, and they are not all used at the same time. They are normally divided into 3 parts. Yes, one for training, which is where the model studies the data. Another for validation, that is used during training to tighten nuts and see how it goes. And a last one for testing, that is totally new data for the model, as a final exam to see how it generalizes.
It has logic, training, validation, and testing, and those nuts that adjust I have heard, and preparations and parameters sound similar.
They sound similar, but they're different. Hyperparameters are like the decisions the cook makes before he starts cooking. What type of oven to use? At what temperature? They are adjustments of the learning process defined by the developer.
Is it worth prior decisions?
That and the parameters are what the model learns during training. They are the weights of the connections in a neural network. For example, it is the knowledge that the model acquires.
Oh, okay. How does the model assess the correctness of its learning process?
Well, with the loss function, it measures how far the model's predictions are from the correct answers. It's like playing darts and measuring the distance to the center. The goal is to minimize that loss, get closer to the center.
Interesting, hey. And before you mentioned that there are different ways to learn, what are the main ones?
Well, basically three strategies. The initial step is supervised learning.
Supervised like with a supervisor, right?
Exactly. You give the model data that already has the correct answer. They're labeled as a student with a teacher correcting them. It is ideal for sorting tasks. This is spam. This is not of regression. Predict the price of a house.
Okay, that seems the most direct. What if I don't have labels?
This is where unsupervised learning becomes useful. You give it the data naked with no answers, and the model has to find patterns or structures on its own.
How does one identify clusters?
Just for example, to group customers with similar purchasing behaviors, clustering, or find products that are usually bought together. Association is like a child sorting Lego pieces by shapes and colors without anyone telling him how.
I see. And what about the third option?
Reinforcement learning. Here you have people like a robot or a program that learns by interacting with an environment, performs actions, and receives rewards or penalties depending on the outcome.
Like training a pet with prizes.
Exactly, trial and error until you learn the best strategy is used a lot in robotics or to train an ace who play video games.
That's incredibly intriguing. Let's shift our attention to language for a moment, shall we? Language certainly seems to be the focal point of many discussions globally. Could you clarify what specifically is meant by one LLM?
Indeed, large language models, often abbreviated as LLMs, represent subsets of deep learning structures developed on an impressive scale.
Brutal, in what sense?
From a numerical perspective, such models encompass billions of parameters and operate with massive datasets for training purposes, which elevate their efficiency. They are basically trained to understand and generate human language coherently.
The most famous example is ChatGPT, of course.
Certainly, he was instrumental in mainstreaming these concepts, describing them as akin to incredibly adept librarians well-versed in nearly all text-based content accessible across the expansive digital platform.
Okay, so how do we communicate with them? I often hear the terms token and prompt being used.
Well, look, tokens are the units into which the model divides the text. They are not always whole words, sometimes they are parts of words or even characters. It's like taking a phrase apart into Lego pieces.
Lego pieces. I like the analogy.
And the prompt is simply the instruction you give the model, the question you ask, or the task you ask. And notice the quality of the prompt is key. Oh, yeah, totally. It's not the same thing to say. He expresses an idea about cats, maybe a short poem about a black cat gazing at the moon from a rooftop. The more specific the prompt, the better the output.
Got it. So crafting good prompts is essential. Also, I came across fine-tuning. What does that mean? Does it involve training from scratch?
Not entirely, and fine-tuning is becoming less dependent on starting from the ground up. It consists of taking one LLM, which has already been pre-trained with a lot of general data.
Base model, let's say.
That's a generalist novel, and you adapt it to a much more specific task or one specific domain using a smaller, specialized data set.
In other words, you adapt and specialize.
Exactly, like a general practitioner who later trains as a cardiologist. It's far more efficient than starting the training process anew. It allows you to take advantage of all the general knowledge of the language that the base model already has.
Very useful, of course. And to finish, let's go back a little to the beginning. How do we measure whether a model is good? What's that SOTA they mistook for a basement?
We came to SOTA to explore deeply. Benchmarks serve as tools to objectively assess and compare various models.
Benchmarks.
They're akin to structured challenges for models to compete. They have a specific dataset, a specific task, and defined metrics to evaluate performance, like the 100-meter smooth in athletics, same distance, same rules for everyone.
It's worth a standard test.
Typically, a baseline represents a simpler model or a previous benchmark used as a reference point to evaluate your new model's progress, similar to establishing your own brand prior to rigorous training.
And then comes the concept of SOTA.
SOTA, or state of the art, refers to the model achieving the highest score on a particular benchmark at a given time, akin to the reigning Olympic champion who holds the record for that specific task.
Oh, now I do. In other words, it is not an absolute quality of the model, but its performance in a specific competition.
Precisely, this measurement relies on metrics for evaluation. Accuracy, often expressed as a percentage of correctness, can be misleading. Imagine a scenario where 99% of emails aren't spam. A model that predicts all emails are non-spam would show 99% accuracy. However, this approach has limitations. Metrics like precision assess how often the model correctly identifies spam out of those it detected, while recall evaluates the proportion of actual spam identified. Balancing precision and recall is critical for better results.
Precision and recall deserve attention since we've had quite a successful streak, right? From Russian dolls of I to machine learning and deep learning concepts. Exploring recipes of algorithms and models, learning paths leading to language giants, fine-tuning processes, and benchmark measures alongside SOTA analyses and achievements.
Yeah, a good review.
We hope that this map of IA slang will help our audience, feel a little more comfortable navigating this world.
Surely yes. And understanding that SOTA refers to performance in a very specific task is essential so as not to get carried away by the headlines sometimes. But this, you see, leaves us with an interesting question to ponder to see if being dumb depends so much on the chosen benchmark of the specific metric, to what extent being number one in that particular ranking directly translates into superior intelligence or into greater real utility for the enormous complexity and variety of real-world problems that rarely look like a clean benchmark.
Good question.
There, I leave something to continue thinking about.